All right, let's jump right into this explainer. When we think of extreme environments, our minds usually go to frozen tundras or maybe dense, humid jungles. But there's this one spot, right in the Mojave Desert, that doesn't really act like a normal desert at all. It's actually way more like a high-powered, naturally occurring convection oven. So today, we're going to unpack the literal geographic recipe that makes Death Valley such a crazy anomaly.
Just to give you an idea of the sheer scale we're talking about here, check out this staggering number. On July 10, 1913, at a place literally called Furnace Creek in Death Valley, the thermometer hit 134.1 degrees Fahrenheit. That's about 56.7 degrees Celsius. And yeah, according to the World Meteorological Organization, that still stands today as the highest official ambient air temperature ever recorded on Earth. Just try to imagine that kind of heat pressing against your skin. It pushes the absolute limits of human endurance.
So, how does a single valley turn into a literal oven? That's really the big question here. It isn't just about being close to the equator, because actually, Death Valley really isn't. It's about a very specific, almost perfectly designed storm of geological and meteorological conditions that all work together to capture heat, compress it, and just absolutely refuse to let it go.
The whole setup starts with three main ingredients. First up, you have a deep basin sitting 282 feet below sea level. Second, a massive wall of 4 mountain ranges completely surrounding it. And third, intensely clear, dry air with basically zero clouds to block the sun. Honestly, if you were trying to engineer a giant oven from scratch using just the Earth's crust, this is exactly the blueprint you'd use.
You really have to picture how Death Valley is physically boxed in. It's essentially a giant bowl. To the west, you've got the towering Panamint Mountains. Over to the east, the Amargosa Range. Then you have the Black Mountains down south and the Grapevine Mountains up north. These aren't just pretty backdrops, right? They're the heavy physical walls of our natural oven, and they dictate exactly how air and moisture behave when they even try to enter the valley. Now, having these massive mountain walls creates something meteorologists call a rain shadow effect. Here's how it works. When weather systems and moisture roll inland from the Pacific, they hit these mountains and get forced upwards. As that air rises up, it cools down, condenses, and dumps all its moisture as rain or snow on the western slopes. So by the time that air mass finally clears the peaks and drops into Death Valley, the moisture has been totally stripped away. The valley floor gets left brutally dry, getting baked by uninterrupted solar radiation all day long.
But here's the kicker. Those mountains do a lot more than just block the rain. As that bone-dry air is forced over the peaks, it plummets straight down into the basin. And remember, that basin is way below sea level. So as the air descends, it compresses really rapidly. And basic physics tells us that when you compress a gas, it heats up. This creates these superheated, extremely dry gusts known as foehn winds. So the sun is baking the valley from above, and at the same time, you literally have superheated air being actively pumped down into the basin.
Because of all this, during the day, the valley floor basically acts like a gigantic solar sponge. There's hardly any vegetation to provide shade, right? So the ground, which is just covered in soil, sand, and these dark volcanic rocks, is fully exposed. With absolutely zero clouds to block that intense summer sun, those dark surfaces just absorb immense amounts of solar energy all day. They get completely supercharged with heat.
Now, you might be thinking, well, don't deserts get freezing cold at night? We've all heard that, right? But Death Valley totally throws that rule out the window. When night falls, all those dark rocks and sands that just spent the last 12 hours soaking up the sun, they start acting like glowing embers in a fire pit. They continuously radiate all that stored heat right back out into the air, steadily all night long.
And this is where the oven comparison really hits the nail on the head. Normally, warm air naturally wants to rise and escape up into the atmosphere to cool off. But remember those steep, high mountain walls we talked about? They block the prevailing winds. So the hot air radiating off the rocks rises a little bit, hits those mountain walls, cools just a tiny fraction, and then gets shoved right back down to the valley floor by those descending foehn winds. The air is completely trapped. It's just circulating and continually reheating. It is quite literally a perpetual heat recycling system.
Thanks to this relentless convection oven effect, summer nights in Death Valley offer pretty much zero relief. During peak heat waves, overnight lows sometimes only dip down to about 82, maybe 98 degrees Fahrenheit. I mean, just imagine trying to sleep when the absolute coolest part of the night is still pushing 100 degrees. The environment just never gets a chance to reset or cool off before the sun comes up, and the whole brutal cycle starts all over again.
This extreme heat cycle brings us to a really important scientific distinction.
When we talk about these crazy climate records, we have to understand the difference between measuring the air temperature and measuring the ground temperature. That official 134.1 degree record from 1913, that's an air temperature. It was measured by a thermometer about 1.5 meters off the ground, tucked inside a ventilated box to shield it from direct sunlight.
And weather stations are fantastic for telling us what the air actually feels like for a human walking around. But over the last few decades, we've launched these advanced satellites into orbit, equipped with some incredibly sophisticated thermal imaging. And while Death Valley definitely holds the official record for the hottest air, these satellites, which are looking directly at the actual surface of the Earth, well, they tell a wildly different and frankly kind of terrifying story.
When we dive into high-resolution satellite data from between 2002 and 2019, this entirely new thermal frontier pops up. Over in Iran's Lut Desert, which, incredibly, has the exact same geographic setup as Death Valley, with mountains trapping heat over dark volcanic rock, satellites recorded a surface temperature of 80.8 degrees Celsius. Let me put that into perspective. That is 177.4 degrees Fahrenheit. It completely dwarfs the air temperature record. The physical ground itself is just vastly hotter than the air floating right above it.
As scientists have pointed out when looking at this data, stepping onto the surface of the Lut Desert, or even North America's Sonoran Desert during these extremes, it wouldn't just be uncomfortably hot. It would literally be like walking barefoot on a boiling sidewalk. We're talking about heat that can instantly burn skin and even melt certain synthetic materials. It really goes to show that while the air might be a record-breaking 134 degrees, the physical earth beneath your boots is absorbing and radiating heat at a level that almost feels alien.
So, this all brings us to a pretty profound realization. We've seen the precise recipe it takes to create these natural ovens, right? The deep basin, the blocking mountains, the dark rocks, the trapped circulating air. But as we keep monitoring both air and surface temperatures in an era of a shifting global climate, we have to ask ourselves a pretty vital question. If places like Death Valley and the Lut Desert are already operating at the absolute limits of terrestrial physics, just how much hotter can our planet's natural ovens get before they break into completely new, unpredictable territory?